Okay, let's move on to this. So a dilation of a polygon is a transformation in which a polygon is enlarged or reduced by a given factor around a given center point. The amount by which it is enlarged or reduced is called the scale factor. All right, to save time, we are not going to do any investigating, but think about it. When we dilate an image, you dilate it through multiplication. So if we're going to dilate it by a factor that's bigger than 1, what do you think is going to happen? Do you think it's going to get bigger or get smaller? So you're multiplying by something that's bigger than 1. It's going to get bigger, right? So if I take something and I multiply it by 3, wouldn't it be triple the size? Right? How do you think you'll make it smaller? So when we're multiplying by something bigger than 1, it's going to get bigger. How do you think you'll shrink something? Multiply by what? Less than 1, right? So between 0 and 1, if you're multiplying by something between 0 and 1, it's going to make it smaller. But if you're multiplying by something bigger than 1, it's going to make it bigger. So the scale factor is greater than 0 and less than 1. The dilation reduces, or sorry, I should say shrinks the figure. When the scale factor is greater than 1, the dilation enlarges the figure. What do you think the scale factor will have to be for it to be exactly the same? So it's not getting bigger, it's not going to get smaller, it stays exactly the same. Jack? 1, you got it. Under a dilation, oh, sorry, I didn't skip this. Under a dilation, multiply the dimensions of the pre-image by the scale factor to get the dimensions of the image. All right, go back right up top. I had skipped it. What happens when the scale factor is 1? The image is the same as the pre-image. Let's keep going. All right, in general, a dilation changes the size of a figure unless the scale factor is 1 without changing its shape. So ultimately, we're just stretching or shrinking. We're not changing the shape. Okay, you don't know this, but we're going to add it in. So it says a rigid motion is a transformation that changes the position of a figure without changing the size or shape. So like a rotation is a rigid motion because you're keeping that shape, but you're just changing how it's sitting. A translation where you slide something is a rigid motion because you're just sliding it to a different position. You're not changing the size or the shape. Do you think dilations are rigid motions? No. Why? Why are dilations not rigid motions? Abby? Because we're changing the size, exactly. Are dilations rigid motions? No, because the size is changed. The biggest thing you need to know is that dilations preserve angle measurements. That's really the main one. So if I have a 30, 60, 90 triangle and I dilate it, no matter what the scale factor is, even though the triangle is getting bigger or getting smaller, the angles stay the same. That's why AAA, angle, 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 is not a way to prove triangles congruent, okay? Because it doesn't preserve the size of the image. So when you dilate an image, its angle measurements stay the same. All right, so how are we going to dilate an image? So right now it says draw the image of the figure below after a dilation with a scale factor of 3/2. That scale factor, 3/2, is that bigger than 1? Yes. So your image, your new image should be bigger. What happens if you find all the coordinates and your new image is somehow smaller? You know you did something wrong, right? If your scale factor is bigger than 1, you know you're going to make the image bigger. Right. So what we want to do is we're going to go to all the pre-image coordinates and list them out. So for example, A right here is the point 3. So this is A. It is the point 3, 0. Somebody tell me, what are the coordinates for B? 0, 2. Somebody else tell me, what are the coordinates for C? -2, 0. What are the coordinates for D? Good. -2, -2. What about the coordinates for E? 1, -2. Okay, now do you guys see that those empty parentheses where it says image? What you want to do is you're going to write the scale factor next to x and y. So that means we're going to take 3/2 of x. So you have multiplied the x coordinate by 3/2, and then you also multiply the y coordinate by 3/2. So 3/2 x, 3/2 y. And that's essentially what we're going to do. And I'll show you what I mean. Right, so I'm going to go down below because this is going to take some work. And I have the coordinate of A, which is 3, 0. I'm going to now come up with A prime. Do you see how I wrote A with that little slash on top? That's written as A prime. That sort of lets us know a transformation has been done. We're creating a new image of the existing A image. And what you do is you're going to multiply the x coordinate of A by 3/2. And you're going to multiply the y coordinate of A by 3/2. So now we multiply. So I'm going to get my A prime, well, 3/2 times 3. 3 times 3 is 9. 2 times 1 is 2. So I get 9/2. And then anything times 0 is what? 0. Because I'm graphing this point, in my mind, for me personally, it's always easier to graph a decimal versus an improper fraction. So I'm going to change this to a decimal. What is 9 divided by 2? 4.5. So we are 4.5, 0. That's my A prime. So I'm going to go now to my chart, and I'm going to write A prime is 4.5, 0. Now, did you guys all see what I did to get A prime? We're now going to do that to B, C, D, and E to get all of their primes. So now let's go on to B prime. So my coordinates for B are 0, 2. I need to now get to B prime. And in order to get to B prime, I'm going to take 3 halves times 0, and then 3 halves times 2. So now my B prime, well, 0 times anything is 0. Now remember, when you're multiplying fractions, can't you cross simplify? So I can cross these two outs, add both the 2's out, and then what do we get? Just 3 times 1, which is 3. So now that's my coordinates for B prime. So B prime is 0, 3. All right, moving on to C. So we have the coordinates -2, 0. And now I need C prime. So I'm going to do 3 halves times -2, comma, 3 halves times 0. So this time, when I cross simplify, I end up with -1. 2 goes into -2, -1 times. So I'm left with 3 times -1, which is a -3. Then anything times 0 is 0. So my C prime is -3, 0. Right, you guys do D and E by yourself. All right, let's go over this. So now we're going to find the coordinates of D prime. So our coordinates for D are -2, -2. We need to find D prime. So we're going to do 3 halves times -2, and then 3 halves times -2 again. 2 goes into -2, -1 times. 2 goes into -2, -1 times. So our D prime coordinate will be -3, -3. And lastly, our E coordinate is 1, comma, -2. We need to now find our E prime. So we're going to do 3 halves times 1. And then -2, 3 halves times -2. So we'll say 2 goes into 1. Oh, sorry, you can't do that. What am I doing? 2 goes into -2, -1 time. And we will get E prime is 3 halves times 1 is just 3 halves. 3 times -1 is a -3. Now remember, I had said that I prefer to plot as decimals. So 3 divided by 2 is 1.5, comma, -3. How many people got those last two coordinates correct? Great. So now it's all about plotting. So my A prime is 4.50. So we're 1, 2, 3, 4 and a half. There is my A prime. Now my B prime is 0, 3. So 0 and then go up 1, 2, 3. Here's my B prime. My C prime is -3, 0. That's right over here. D prime is -3, -3. And lastly, my E prime is 1.5 and then -3. And then all you want to do is connect the dots to create your new image. And here is our new image, 1.5 times bigger than our pre-image. All right, so that is the end of dilations. Now let's go on to section 8.2. I do want you to do the do now. So go into section 8.2. I'm going to have you do the do now. Okay, I printed it. Yep. Okay, let's go over this. So it says a recipe calls for 1/3 cup of flour to make cake for 10 people. So really what's comparing here or what's correlating here? The cups of flour for every X amount of people. So what I'm doing is I'm going to put the cups on top and the amount of people on the bottom. That's what I decided. That's what I'm going to stick with. So it says 1/3 of a cup for every 10 people. I'm going to write it just like that. So now it's saying how many cups of flour are needed for 15 people. Where do I put that 15? In the numerator or in the denominator? In the denominator. And they're saying how many cups of flour. So I'm going to put an X in my numerator. Don't get intimidated by the fraction. We are just going to cross multiply like we do. And we will get 10x is equal to 1/3 times 15. Well, when you're multiplying fractions, you can cross simplify. So 3 goes into 15 5 times. So here we have 10x is equal to 5, divide by 10, and we get x is equal to 5 over 10. But what does that reduce to? 1 over 2. So we're going to have half a cup for the 15 people. All right. So today we're going to talk about similar figures. Similar figures are figures that have the same shape, but not necessarily the same size. Right, what do I mean when I say not necessarily the same size? Can it be the same size? Sure. Does it have to be the same size? No. So here's an always, sometimes, never for you. Congruent figures are similar. So by definition, similar figures are figures that have the same shape, but not necessarily the same size. So congruent figures are similar. How many people say always? How many people say sometimes? How many people say never? Okay, Emily wins. It was always. Why? Why is it always? By definition, congruent shapes have the same shape, same size, right? Congruent figures, same shape, same size. Well, doesn't that fit the definition of similar? Similar saying you have to be the same shape, you can be the same size, you don't have to be the same size. So doesn't congruent meet that definition and then beyond it a little bit? Right? So congruent figures are always similar. Now let's reverse that. Similar figures are congruent. How many people say always? Similar figures are congruent sometimes. Congruent figures are similar never. Good. It is a sometimes. All right. Similar polygons are polygons in which the ratio of the measure of corresponding sides are equal and corresponding angles are congruent. All right, it's very similar to triangles, congruent triangles. Similar triangles, the way the letters are written absolutely matters. And do you see how I put a little squiggly between these two triangles? Right, that little squiggly means similar. This little squiggly means similar. Oops, don't want to X that out. This little squiggly means similar. So when I'm telling you that triangle ABC is similar to triangle DEF, this means that the corresponding angles have to be congruent. So which angles correspond? Well, since A is written first and D is written first, that means angle A has to be congruent to angle D. And angle B, since it's written second and E is written second, angle B has to be congruent to angle E. And since C and F are written last, that means angle C will be congruent to angle F. Now here's the different part. Now the corresponding sides, the sides that match up, they're not going to be congruent. They are going to make equal ratios. What do I mean when I say equal ratios? Well, if we pair the corresponding sides, so for example, see how AB is written first and DE is written first? That means, and there's no tick mark for just corresponding, I'm just going to highlight, that means AB will correspond to DE. So if we make a ratio of their sides, AB over DE, I get 8 over 4. But what does 8 over 4 simplify down to? Not a half. 2 over 1, right? That means every pair of corresponding sides will simplify down to 2 over 1. Let's check it out. So which side corresponds to BC? EF, because they're both written the last two letters. So now when we look at BC to EF, let's change up our color actually, do this one. BC to EF is going to be 10 over 5. Well, what's 10 over 5? 2 over 1. Right, and let's match up the last pair of corresponding sides. You pair your first and your last. So I'm pairing AC and DF. They correspond to each other. So I have AC corresponds to DF. So when I see AC is to DF, we're going to have 12 over 6, which reduces down to 2 over 1. And this is not a coincidence. When the figures are similar, the ratio of the corresponding sides all simplify down to the same number. All right, let's do a problem. So it says given ABCD is similar to EFGH, angle A is 30 degrees. So I'm going to label my angle A as 30 degrees. Now we want to find the ratio of the sides. In order to find the ratio of the sides, you need two sides that correspond that both have lengths written. So do we see how there's a 6 written for AB and there's a 9 written for EF? We have to make sure that they correspond. How do I know if they correspond or not? If those are the sides that correspond. PJ? Well, we don't know which sides, we don't know which sides the other ones are to make the same ratio. So how will I know which ones match up? I know. Kyla? How it's written in the given. So right now, do we see how AB is written first? What does that mean? AB has to correspond to EF. Do they correspond? Yes. So now you have to decide. And once you decide this, Brendan, once you decide this, you want to make sure that you stay consistent. Which figure do you want to be in the numerator and which figure do you want to be in the denominator? This initial time when we're deciding, it doesn't matter. But then after that, you have to stay consistent. So I'm going to decide that A, B, C, D will be in the numerator and that E, F, G, H will be in the denominator. Now I've decided that. So every time I make a ratio, what needs to be in the numerator? A, B, C, D. What has to be in the denominator? E, F, G, H. If at any point I switch it, I'll end up doing something wrong and getting the wrong answer. So once you decide, you have to stay consistent. All right, so find the ratio of the sides. Since I said A, B, C, D is going in the numerator, we're going to say 6 over E, F, G, H, which is 9. But what does 6 over 9 simplify down to? 2/3. So the ratio of the sides is 2 to 3. So now we want to find the length of FG. So I'm going to go to FG. I'm going to call it X. And what we're going to do is, because these figures are similar, that means that every pair of corresponding sides has to simplify down to the same ratio. So I'm always going to start off using the sides that they gave me that I know correspond. So we're going to say AB is to EF, so AB over EF equals, now I need to find FG. Where am I going to put FG? In the second numerator or the second denominator? And why? Good. We're going to put it in the denominator to stay consistent because we said EFGH parts are all going in the denominator. So now, what corresponds to FG? Well, we have to look. So FG is second and last. So second and last on the other side is BD. Oh, FG is second and third, not second and last, sorry. Second and third, then second and third, that's going to be BC. So we have AB over EF equals BC over FG. Now we put in the numbers. Well, didn't we already decide that AB over EF was 2/3? Didn't we do that already? So we're going to use the 2/3. So 2 over 3 is equal to BC, which is 4, over FG, which is X. Now we cross multiply and solve, so we get 2x equals 12, so x will equal 6. All right, next one. Oh, FG is 6. Now we want to find GH. Same thing. We use the original AB over EF. And we want to find GH, which I'm going to call Y. GH, to stay consistent, will go in the denominator. And which side corresponds to GH? Anybody? Which side corresponds to GH? CD, good. So now we're going to plug in AB over EF, we said was 2/3. That's going to equal CD, which is 3, over GH, which is Y. Cross multiply, we're going to get 2Y equals 9. So Y equals 9/2, or 4.5. I want you guys to find EH by yourself. I'm going to call EHW. All right, so what we should have gotten is 2 over 3 equals 7 over W. Cross multiply, 2W equals 21. W will equal 10.5. How many people got that? Perfect. All right, now it says find the measure of angle E. Now remember, when the figures are similar, the sides make equal ratios, but the angles are what? Congruent. So we have to figure out which angle corresponds to angle E. Well, E is written first. That means A has to correspond to E. How many degrees is angle A? 30, which means E is also 30 degrees. All right, part B. Find the ratio of the perimeter, so perimeter of A, B, C, D, to the perimeter of E, F, G, H. The order matters. Whatever they write first has to be in the numerator. Whatever they write second has to be in the denominator. So I need the ABCD perimeter over the EFGH perimeter. So let's go ahead and calculate. 7 plus 3 is 10. 6 plus 4 is 10. 10 plus 10 is 20. Now we're going to find the EFGH perimeter. 9 plus 6 is 15. 10.5 plus 4.5 is 15. 15 plus 15 is 30. What can I do with this 20 over 30? Simplify it. So what's the perimeter of ABCD to EFGH? 2 to 3. Have we seen this before? This number? Wasn't that the ratio of the sides? That's not a coincidence. Anytime two figures are similar, the ratio of their perimeters will be the same as the ratio of their sides always. And sometimes we'll need to know that to solve the problem. All right, the ratio of the perimeters of two similar polygons equals the ratio of the pair of corresponding sides. Am I doing on time? Okay. I'm trying to pick the more important problems to do. All right, let's do this. Number 4. I'm jumping around here. All right, given triangle below are similar. AB is parallel to DE. Label the angles that are congruent. So using the parallel lines, do you all see the Z here? Because of that Z, what does that tell me? That angle A has to be congruent to which angle? E. Do we see the Z on the other side? Like this. So which angles have to be congruent because of that Z? B and D. And you guys see how angle 1 and 2 are vertical angles? So they have to be congruent. So we labeled the angles that are congruent. Now what I want to do is I want to highlight the sides that correspond to each other. Now this time they didn't tell me how these triangles are similar. But I just know that they are similar. The way I'm going to find how the sides correspond to each other is by the marking of the angles. Do you see how AC has a loop with a slash to just a loop? So I have to find which side in this triangle has a loop with a slash to just a loop. So like D to C has a loop with 2 slashes to a loop. That's not what I want. I want a loop with 1 slash to just a loop. Which side is that? Jack? Yeah, good. The CE. Very good. So that means AC and CE correspond. Tell me which side corresponds to BC. CD, you got it. And then by process of elimination, doesn't that mean that AB and DE correspond to each other? Okay, so now we have to write the letters in the right order. So I wrote triangle ACB. So which angle corresponds to A? No, E. So we're going to write E first. Then it's C. Which letter corresponds to C? C. Then it's B. Which angle corresponds to B? D. So it would be ECD is how we write the next triangle. All right, now they're asking us to find X. So what do we want? Which triangle do we want on top? We have to decide right now. Do you want ABC on top or DEC on top? Sure. So we're going to say triangle ABC over triangle EDC. So I'm asked to find X. Yes. ACB. I wrote ABC, and then I wrote EDC. I still correspond. They're the same triangles.
Well, no, because it says ACB is congruent to ECB. You wrote it ABC.
And then I wrote EDC.
Oh, okay. Sorry.
It's okay. All right, so here we want to solve for X. Do we agree X is the bottom triangle in the denominator? So here I'm going to put X. Which side corresponds to X? 6 corresponds to X. Now I need, aside from a purple aside from triangle ABC and triangle DEC, two sides that both have numbers. Which two sides both have numbers that correspond? 12 and 8. Do they correspond? Yeah, that's going to be this fraction. Which one has to go on top? 12 has to go on top. So I'm going to do 12 over 8. Before I cross multiply, can I simplify the 12 over 8? Yeah, I could divide by 4. So I'll get 3 halves is equal to 6 over x. Cross multiply, we get 6x equals 12. X will equal 4. Right, now I'm going to do the same idea, but for y. So I'm still going to use the 3 over 2. Now I'm looking for y. So y, guys, is right over here. I just circled it. There's y. So y is going in the denominator. Which side corresponds to y? 9. Good. So now we have 3y equals 18. Y will equal 6. What did we figure out the ratio of the sides is? I heard it. Gabby?
3 over 2.
Good. 3 over 2. The ratio of the sides is 3 over 2. Well, didn't we just learn that the ratio of the sides and the ratio of perimeters are the same? So the ratio of the perimeters is also 3 over 2. All right, I need to get through at least this last problem. All right, there will be a question like this on your quiz. This is why I want to go over this. A rectangle has sides 4 and 10. So you're going to draw a rectangle, has one side 4, one side 10. If a similar rectangle has a perimeter of 70, find the length of the longer side. Find the length of the longer side. Why did I put the X on top and not on the side? Any ideas? Abby? Yeah, how did I know that's the side I'm trying to find? Wouldn't the longer side of the second rectangle correspond to the longer side of the first? So since the 10 I put up here is the longer side, I put the X up here because they have to correspond. The longer sides have to correspond. Now, in a rectangle, aren't opposite sides congruent? Because a rectangle opposite sides congruent, I know if the left side is 4, the right side is 4. If the top is 10, the bottom is 10. So what is the perimeter for this one? 28. All right, so now we want to find X. Usually I pair the corresponding sides to find the ratio of the sides. I don't have that. But isn't the ratio of the perimeters and the ratio of the sides the same? So that's what we're going to use. So I'm going to say 28 over 70 is equal to, what do you think I'm going to put now? Because I have to find X. PJ? 10 over X. Would I have been allowed to do X over 10? No, we have to stay consistent. All right, so now 28 over 70, I can reduce that. I can divide by 7. So I'm going to get 4 over 10 equals 10 over x. I can reduce this again, actually, and get 2 over 5 equals 10 over x. So we're going to get 2x equals 50, so x is equal to 25. All right, that's all the problems I wanted to do just in the nick of time.